Good afternoon, my dear students. Today I am going to solve some essential problems related to differential calculus of first order and second order. As we know that the differential calculus is a vital topics for the students of class 12 and also for the students appearing in the coming board exams and entrance exams all over the country. As we know that the differential calculus is a part of the entire calculus. The entire calculus is divided into two different branches. First branch is differential calculus, the second branch is integral calculus. But today we are trying to solve some problems on differential calculus. It has a vital application in the field of maxima minima and in the rate measure. With the help of the differential calculus, we can measure the rate of a variable with respect to some other variable. And also with the help of this differential calculus, we can find out the maxima and minima of a function with respect to some other variable and which are related to real life problems. So finally we can say that differential calculus has the application in solving real life problems. That is why we need to strong in these topics, and if we strong in differential calculus, then we can easily be strong in integral calculus, and if we are in strong in integral calculus, then we must be strong in differential equation. So these are all related to each other. That is why this topic is very much important. So let us start our problem. First of all, we start with derivative of a function with respect to derivative of a function with respect to another function. Today I shall differentiate a special type of function with respect to some another type of function. So if we want to differentiate this function with respect to that function, then first of all we assume that let u is equal to tan inverse t over 1 minus t square root over, and b is equal to sec inverse 1 over 2t square minus 1. Since we have to differentiate u with respect to b, that is we need to find out du dv. We have to differentiate u with respect to b, so we need to find du dv. So this one our requirement. So first we have to simplify this function to assume that let t is equal to cos theta. Then u is equal to tan inverse of cos theta divided by square root of 1 minus cos square theta. That means, as we know that root under 1 minus cos square theta equal to sin theta, so here it is equal to cosine theta divided by sin theta. That is tan inverse of cot theta, or tan inverse of tan pi by 2 minus theta, because we know that cot theta is equal to tan pi by 2 minus theta. Tan inverse cancel, so we get pi by 2 minus theta. This is u. That is we find that this u is equal to pi by 2 minus theta means cos inverse t. Here also sin theta, cos theta, etc. But it is not necessary to take the assumption in both u and v are same. There may be different assumptions, but here we have the same assumptions. T is equal to cos theta. Then v becomes sec inverse of 1 over 2 cos square theta minus 1. Then as you know that 2 cos square theta minus 1 is equal to what? It is equal to cos 2 theta, that is sec inverse of sec 2 theta. Sec inverse cancel, we get 2 theta. Now theta means cos inverse t, that is 2 into cos inverse t. This is what? B. This is V. So we got V is equal to this and U is equal to this. Now we differentiate U with respect to t because U is a function of t. So we differentiate U with respect to t, we get derivative of constant equal to 0 minus cos inverse t, derivative of cos inverse t is equal to minus 1 over root under 1 minus t square. This one, that is finally got 1 over root under 1 minus t square. But here differentiating B with respect to U with respect to t, and we get 2 into cos inverse t, that is minus 1 over root under 1 minus t square. This one, that is minus of 2 over root under 1 minus t square. This is dv dt. As we need to find out du by dv, so we must divide dv. Now dv du is equal to dv dt divided by du dt, that is minus 2 over root under 1 minus t square divided by this one 1 over root under 1 minus t square. This 1 root under 1 minus t square cancel out, then we get minus 2 only. So dv du is equal to minus 2. This is our answer. Okay, this is the first problem. Now I am coming to solve some problems related to parametric functions. Now parametric functions. Now we solve some problem related to parametric functions. The problem number 2, if x is equal to a cot theta, y is equal to 1 over x square plus s square, then show that we have to show that d2y that is y2 is equal to 2 over a power 4 into sine cube theta into sine 3 theta. This one. Okay. Now first x is equal to a cot theta and y is equal to this. So we start to solve this problem. Y is equal to 1 over x means a cot theta, so a square cot square theta plus s square. This is equal to 1 over x is equal to a cot theta. This is equal to 1 over that is 1 over s square into cot square theta plus 1. It is cos square theta plus 1 is equal to cosec square theta, that is sine square theta divided by s square. This one is equal to y. Our second order derivative is equal to that part, we will show. Now this one is equal to y. Now y is a function of theta and x is a function of theta. This is a parametric form because x and y both are function of a third parameter theta. So in this case we differentiate y with respect to theta. Since y is a function of theta, 1 over s square is a constant one, and so sine square theta, derivative of sine square theta is equal to 2 sine theta into derivative of sine theta is equal to cos theta. Okay. And here we find dx d theta is equal to a into minus of cosec square theta, that is minus a cosec square theta or a over sin square theta. Now dividing dy by d theta, we need to find first dy by dx. What is dy by dx? Dy by dx is equal to 1 over a square into 2 sin theta cos theta divided by this one minus a over sin square theta, that is minus 1 over a cube into 2 sin cube theta into cos theta. This one, this is dy by dx. Next, now we need to find d2 by dx2. Now ddx of dy by dx is equal to ddx of minus 1 over a cube or 2 over a cube into sin cube theta into cos theta. Okay, minus 2 over a cube constant. So since this function is a function of theta and here we are differentiating, we are with respect to x, so it is not possible to differentiate a function of theta with respect to x. So we need d theta. We differentiate this function with respect to theta, so sin cube theta into cos theta and d theta dx. Okay, therefore minus 2 over a cube dd theta. So here we find the product rule and uv rule. So sin cube theta into derivative of cos theta minus sin theta plus. Now we have the derivative of sin cube theta is equal to 3 sin square theta into derivative of sin theta cos theta and cos theta, and what happened, and it is equal to cos theta. So cos theta remains same here, and whole thing into d theta dx. Now what is d theta dx? What is d theta dx? D theta dx is equal to minus a over sin square theta. So it will be is equal to it will be reciprocal. If you inverse, if we take what d theta dx means 1 over dx d theta. So dx d theta equal to this, that is reciprocal. So sin square theta divided by minus a, this one. Now minus 2 over a cube, and here we find that this one sin 3 sin square cos square theta minus sin power 4 theta, and here if we calculate this part, we get this is positive sign and a power 4. Okay, and here it is sin square theta. Now 2 over a power 4 and 3 sin square theta into cos square theta minus sin power 4 theta into sin square theta. Okay, now taking sin theta common, we have 2 over a power 4 sin theta, this sin theta, so sin square theta, here it is sin cube theta, so 3 sin theta minus 4 sin cube theta. Okay, so therefore we find that d2y dx2 is equal to 2 over a power 4 into sin cube theta into sin 3 theta. This is the formula for sin 3 theta. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. So this is our answer, hence proved. Okay, this is the second problem. Now another parametric function is that, now we solve the problem number 3. Problem 3 is if x is equal to a into theta minus sin theta and y is equal to a into 1 minus cos theta, show that 2y y2 plus cosec square theta by 2 is equal. Now problem number 3. This problem states that if x is equal to this and y equal to this, a function of theta, then show that this part. So here also we find both and y are parametric function here. So differentiating what is x is equal to a into theta minus sin theta. So differentiating x with respect to theta, we get a into 1 minus cos theta, and y is equal to a into 1 minus cos theta, that is dy d theta is equal to a into 0 plus sin theta, that is what, this is equal to a sin theta, dy d theta equal to a sin theta, dx d theta equal to this. Therefore dy dx is equal to a sin theta divided by a into 1 minus cos theta, that is a cancel, sin theta means 2 sin theta by 2 divided into cos theta by 2 whole divided by 1 minus cos theta means 2 sin square theta by 2. So 2 cancel, sin theta cancel, so cot theta by 2. This is the value of dy dx. Now the differentiating with respect to x, again we get d to y dx to this one, and in the right side d dx of cot theta by 2. Since cot theta by 2 is a function of theta, we differentiate this with respect to theta, that is d d theta of cot theta by 2 into d theta by dx, d theta by dx. Now cot theta by 2 means minus of cosec square theta by 2, and derivative of theta by 2 is equal to half into 1, and d theta by dx, this is equal to this one, the reciprocal of this one. So what is the reciprocal? 1 over a into 1 minus cos theta, this one is the reciprocal one. Now minus of 1 over 2 sin square theta into 1 over a into 2 sin square theta by 2, this, and this is equal to what? This is equal to minus 1 over a into 4 sin square theta by 2 means 2 sin power 4 theta by 2. Okay, now therefore my left hand side is equal to 2y into y2 plus cosec square theta by 2. Now 2 into y means a into 1 minus cos theta, and y2 means minus 1 over a into 2a into sine power 4 theta by 2, this one, plus cosec square theta by 2. Now 2a cancel, and 1 minus cos theta, here minus 1 minus cos theta equal to 2 sine square theta by 2. Divided by actually this one is equal to 4, here it is 4, this one is equal to 4, so this cancel 2, so here we find that 2 sine power 4 theta by 2 plus cosec square theta by 2, so 2 cancel, sine square theta cancel, so we get minus of 1 over sine square theta by 2 plus cosec square theta by 2, that is cancel, is equal to 0, equal to right hand side, this one. Now we shall solve problem related to inverse function. Inverse function. Problem number 4. Now problem number 4. Let if y is equal to tan inverse 4x by 1 plus 5x square plus tan inverse 2 plus 3x over 3 minus 2x, then prove that dy by dx is equal to 5 divided by 1 plus 25x square. Okay, the first we start, y is equal to tan inverse 4x by 1 plus 5x square can be written as 5x minus x divided by 1 plus 5x into x plus tan inverse, we can write this as dividing both numerator and denominator by 3, we get 2 by 3 plus x 1 minus 2 by 3 into x. Now this one is a formula related to inverse function, and we know that in inverse function, if tan inverse a minus b by 1 plus ab, this is equal to tan inverse a minus tan inverse b plus here it is equal to tan inverse 2 by 3 plus tan inverse x. So this one cancel. Now we get y is equal to tan inverse 5x and tan inverse 2 by 3. This one is a constant, this one is a constant one because it does not depend on x. So now differentiating y with respect to x, we get dy dx is equal to what? Tan inverse 5x, that is 1 over 1 plus 5x whole square into derivative of 5x, that is equal to 5 into 1, and the derivative of constant is equal to 0. So we get 5 over 1 plus 25x square. This one is our answer. This is number 4. Now exponentiation function. Exponentiation function. exponentiation function. So problem number 5. If y is equal to 10x power 10x whole power 10x, find dy by dx at x is equal to pi by 4. This is an exponentiation function. Base is a function, power is also function. Now y is equal to 10x whole power 10 square x, this one. By the laws of indices we get these two will be multiplied, 10 into 10, 10 square x, and that will be at the power of 10x. So 10x is base and power is exponent. So we have the law of exponentiation function of derivative. So actually we know that ddx of b power e, base power exponent, it is equal to base power exponent into exponent by base into derivative of base plus logarithm of base into derivative of exponent. Now according to the law of exponentiation law, we get dy dx is equal to 10x power 10 square x into exponent by base into derivative of base, that is derivative of 10x, this is equal to sec square x, plus logarithm of base, that is logarithm of 10x into derivative of exponent, that is derivative of 10 square x means 210x, and derivative of 10x is equal to sec square x. So this one. Now simplifying we get sec square, taking sec square common we get here, it is equal to sec square x. So 10 square by 10 square 1 and cancel, so we get 10x plus 210x into log of 10x. Taking 10x common again we get 10x whole power sine square x plus 1, because 10x will be multiplied with this part, into sec square x into 1 plus 2 log 10x, this one. And we have to find it at the value of x equal to pi by 4. Now we put the value of x is equal to pi by 4 on the right side. We get 10 pi by 4 is equal to 1. Sine square pi by 4, that is sine square pi by 4 equal to 1 by root 2, so 1 by root 2 square plus 1 into sec pi by 4. Sec pi by 4 means root 2 square, 1 plus 2 into log 10 pi by 4 1, that is we get 1 power half plus 1 power anything is 1, root 2 square, that is 2, and here 1 plus 2 into 0, so we get 2 only. This is our answer. Now implicit function. Implicit function. Implicit function. How to show the how to differentiate an implicit function? We will show this by means of an example here, and let us take the function as say problem number 6. Find dy by dx if logarithm of xy is equal to e power x plus y plus 2. We have to find out the derivative of y with respect to x, that is dy by dx, when this implicit function was given. This is an implicit function because an implicit function involves two variable or more variable and as an equation form. Okay, as an equation form. Now we will differentiate. Given function is log of xy is equal to e power x plus y plus 2. So we can apply the formula of logarithm here. We know that log mn is equal to log m plus log n. So here log x plus log y by formula related to logarithm, and here e power x plus y plus 2. Now differentiating this term by term with respect to x, we get 1 over x plus 1 over y into dy by dx, and here e power x plus y by chain rule, e power x plus y derivative of this is equal to e power x plus y into ddx of x plus y, and derivative of 2 is equal to 0. Now 1 over x plus 1 over y into dy by dx, that is y1, is equal to e power x plus y into, here we find 1 plus y1. Okay. So multiplying on the right side, we will get e power x plus y plus e power x plus y into y1. That is, now we have to find out dy by dx, that is y1. Now from right side transposing, we get y1 by y minus e power x plus y into y1 is equal to e power x plus y minus 1 over x. That is, taking common y1 on both sides, we get 1 over y minus e power x plus y is equal to e power x plus y minus 1 over x. This one. So dividing, we will get y. If we divide this, we will get y. Now y1 is equal to e power x plus y minus 1 by x whole divided by 1 over y minus e power x plus y. Okay. X e power x plus y minus 1 by x into y divided by 1 minus y e power x plus y. After simplifying, we get this. So y over x into e power x plus y minus 1 okay. This one is our result. Now we will solve another problem regarding implicit function. Let us say find problem number 7. Find dy by dx if it is given that y power x plus x power y plus x power x is equal to a power b. Now again we have an implicit function here. So given function is y power x plus x power y plus x power x is equal to a power b. So using the exponentiation law of differentiation, we will get here derivative of this term is equal to y power x into exponent by base into derivative of base, that is derivative of y is equal to y1 plus logarithm of base y log y and derivative of exponent, that is derivative of x, is equal to 1. This part, this is the derivative of first part. Second part, x power y into exponent by base into derivative of base, that is derivative of x is equal to 1 plus logarithm of x into derivative of y, that is y1, this one, plus derivative of x power x, this is equal to x power x into exponent by base into derivative of base plus logarithm of base into derivative of exponent, and right hand side it is equal to 0 because a power b is a constant, so derivative is 0. Now we will take those terms involving y1. So taking y1 common, we get here x into y power n minus 1 x power y into log x this one, and in the right side we will get minus of y power x into log y plus x power y into log x, x power y minus 1 into y plus x power x into 1 plus log x. Whole over x into y power n minus 1 plus x power y into logarithm of x. This one is equal to second step, we get this, therefore y is equal to dividing this, we get the result. This one 7. Now we will show some explicit function. Till now we solve some problems related to implicit function. Now we will solve some explicit function. We have already solved explicit function. In explicit function we find that one variable is a function of some other variable, then it is explicit function. The general form is if y is a function of some other variable, then this is an explicit function. If say t is a function of some z, then this is an explicit function. So in this case we take one example 8. If y is equal to tan inverse of a cos x minus b sin x whole divided by b cos x plus a sin x. Now to show that derivative of y with respect to x is equal to minus 1. Now we start, y is equal to tan inverse of dividing both numerator and denominator by cos x, we get dividing both numerator and denominator by b cos x, we get a by b minus tan x divided by 1 plus a by b into tan x. Now applying inverse trigonometric function, we will get here tan inverse a over v minus tan inverse of tan x that is tan inverse of A over B minus tan inverse cancel, we get x. So y is equal to this. Therefore dy by dx is equal to, this one is a constant, it does not involve x, so it is a constant, so derivative of constant is equal to 0 minus derivative of x 1, that is equal to minus 1, hence problem. Now from the given equation we can get x is equal to cos y divided by cos a plus y. That is, here it is easy to express x as a function of y. Now we then differentiate x with respect to y, we get cos square a plus y, u by v rule, quotient rule of derivative. Applying quotient rule of derivative, we get cos square of this a plus y. So cos a plus y into derivative of cos y, that is minus of sin y, minus cos y remains same, derivative of cos of a plus y is equal to minus of sin a plus y, and derivative of a plus y is equal to 1. So we get here minus minus plus, that is sin a plus y into cos y minus cos a plus y into sin y, whole divided by cos square a plus y. That is, here we find that sin of a plus y minus y, whole divided by cos square a plus y cancel, so sin a divided by cos square a plus y. This is our dx by dy. Now what is dy dx? What is dy dx? Therefore dy dx is the reciprocal of this function, that is cos square of a plus y divided by sin a, hence proved. Okay. Now find dy dx if y is equal to, another problem, problem number 10. Find dy dx if y is equal to cos inverse a plus b cos x divided by b plus a cos x. Now since y is equal to this, so we shall differentiate y with respect to x directly. We know that cos inverse x, derivative of cos inverse x is equal to 1 over root under 1 minus square x square, means a plus b cos x divided by b plus a cos x, this square, into the chain rule, derivative of this, so d dx of a plus b cos x over b plus a cos x. Now simplifying this function, we get b plus a cos x whole square minus a plus b cos x whole square, and from square root it will cancel, we will get b plus a cos x here. Okay. Multiplying this by b plus a cos x whole square, applying the quotient rule, we get b plus a cos x into derivative of this is equal to minus of b sin x minus a plus b cos x into derivative of b plus a cos x, this is equal to minus a cos x. Now simplifying, we get this one part cancel, and in the numerator we will get b plus a cos x minus of this, and this is minus minus plus. First we multiply this part, a cos s square cos x, s square cos x plus ab cos square x, and here minus b square sin x minus ab sin x cos x. Okay, so this one equal to sin x, a sin x. So minus s square sin x. This part is actually s square sin x, and this one equal to ab sin x cos x, ab sin x cos x, ab sin x cos x. So this one cancel, and in the denominator we find that b plus a cos x into root under this one, b square plus 2ab cos x plus s square cos square x minus s square minus 2ab cos x minus b square cos square x. So this part cancel, so we get s square sin x minus b square sin x. So s square minus b square into sin x divided by b plus a cos x. Here b square minus s square, root under b square minus s square, and then minus of b square minus s square cos square x. So s square minus b square into sin x divided by b plus a cos x into b square minus s square. Taking common, we get 1 minus cos square x, that is sin square x. So finally we get a square minus b square into sin x, and here we find b plus a cos x into sin x into root over b square minus s square. So sin x and x cancel, and we get 1 over minus of a square b square minus s square over b plus a cos x into root over b square minus s square. So finally we get minus of root over b square minus a square whole divided by b plus a cos x. This one, this is the answer. Next problem. Problem number 11. Problem number 11. If y is equal to x minus e power minus x square divided by 2x square prove that x into dy by dx plus 2y is equal to 1 over 2x plus e power minus x square. Now let us start to show that our given part is equal to y is equal to x minus e power minus x square divided by 2x square. So cross multiplying we get 2x square y is equal to x minus e power minus x square. Now differentiating with respect to x we get 2 into 2x into y plus x square into y1 is equal to 1 minus e power minus x square into minus 2x. Okay. Now multiplying we get so taking x common on both sides, so 2x x we get 2y plus x y1 is equal to 1 minus 1 plus 2x into e power minus x square. So dividing by 2x we get x y1 plus y is equal to 1 over 2x plus e power minus x square. Hence proved. This is number 11. Now another problem. 12. Problem number 12. Now we will solve another problem. Problem number 12. If y into root over x square plus 1 is equal to logarithm of root over x square plus 1 minus x, show that x square plus 1 into y1 plus xy plus 1 is equal to 0. So what is given? The given function is y into root under x square plus 1 is equal to logarithm of root under x square plus 1 minus x. Now it is a function, the given condition. Now we differentiate with respect to x on both sides, we get y into derivative of this part is equal to 1 over 2 root under x square plus 1 into derivative of x square plus 1 is equal to 2x plus root under x square plus 1 into derivative of y is equal to y1 is equal to right side. Derivative of logarithm function is equal to 1 over root under x square plus 1 minus x into derivative of this part. So 1 over 2 root over x square plus 1 into 2x minus 1. 2 to cancel. Now 2 to cancel. So xy over root under x square plus 1 plus root over x square plus 1 into y1 is equal to 1 over root under x square plus 1 minus x, this one into here taking LCM we get root over x square plus 1 x minus root over x square plus 1, this one. Multiplying by root over x square plus 1 we get xy plus 1 plus x square into y1. In the right side cancelling we will get minus of taking negative common root over x square plus 1 minus x divided by root over x square plus 1 minus x, this one we cancel minus 1. So we get xy plus x square plus 1 into y1 is equal to minus 1. Hence proved. Problem number 12. It is complete. Now problem number 13. If square root of 1 over x power 2n plus square root of 1 minus y power 2n is equal to a power n into x power n minus y power n, show that dy by dx is equal to x by y power n minus 1 root over 1 minus 2 power y power 2n divided by 1 minus x power 2n. We shall show this one. So it's a very important problem, and it is more complicated than any other functions, and here we'll have to assume a suitable function. Now root under 1 minus x power 2n plus root under 1 minus y power 2n is equal to a power n into x power n minus y power n. We choose x power n is equal to cos theta and y power n is equal to cos phi. Then we get from the given equation number 1, therefore 1 then reduces to square root of 1 minus cos square theta plus square root of 1 minus cos square phi is equal to a power n into cos theta minus cos phi, this one. So here we find sin theta plus sin phi is equal to a power n into cos theta minus cos phi. Clear? Then we get sin theta plus sin phi divided by cos theta minus cos phi is equal to a power n. Now we know that sin theta plus sin phi is equal to 2 sin theta plus phi by 2 into cos theta minus phi by 2 whole divided by 2 cos c minus cos t, that is this is equal to minus of 2 sin theta plus phi by 2 into sin theta minus phi by 2. This is equal to a power n. Now cancelling sin and 2 we get cos by sin minus of cos by sin means actually cos by sin is equal to cot theta minus phi by 2 is equal to minus of a power n, and then we will get theta minus phi by 2 is equal to cot inverse of minus of a power n, that is theta minus phi is equal to 2 cot inverse of a power n, and the right side function is a constant function, and then therefore theta minus phi. Theta means cos inverse x power n minus phi means cos inverse y power n is equal to 2 cot inverse minus of a power n. This one is minus. Now differentiating with respect to x on both sides, so you will get here 1 over root under 1 minus x power n whole square into derivative of x power n is equal to n into x power n minus 1 minus here same minus 1 here minus 1 over root under 1 minus y power n whole power 2 and derivative of y power n is equal to n into y power n minus 1 into derivative of y1. In the right side it is equal to 0 because it is a constant, derivative of constant is equal to 0. Therefore minus minus plus, so we get n y power n minus 1 into y1 over root under 1 minus y power 2n is equal to n into x power n minus 1 over root under 1 minus x power 2n. Okay. Therefore y1 is equal to is n cancel, y1 is equal to x power n minus 1 over y power n minus 1 into root under 1 minus y power 2n divided by root under 1 minus x power 2. This one is our proof, hence proof. Now problem number 14. Problem number 14. If fx is equal to logarithm of base x of log of x base e, find f dash e eta. It is, we have to find out f dash e. We have given fx is equal to this function. Now first of all we write fx is equal to logarithm of log x base e divided by logarithm of x. By the law of logarithm we can write this function as this form. Here base is e. Now f dash x, differentiating this ratio, law derivative ratio of law of the derivative, so it is equal to log x whole square log x into derivative of this means 1 over log x and derivative of log x is equal to 1 over x minus log of log x into derivative of log x 1 over x. Okay, log x cancel, so 1 over x common, we get 1 minus log of log x whole divided by log x whole square. This is f dash x. Now f dash e, replacing x by e, we get 1 over e 1 minus logarithm of log e base e divided by log e base e whole square. 1 over e 1 minus log e base e 1 1, log 1 equal to 0, so 1 minus 0 divided by 1 square, that is equal to 1 over e. This is answer. Next problem 15. Now 15. Problem number 15. If y is equal to root under sin x plus root under sin x plus root under sin x plus dot 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 up to infinite, show that dy by dx is equal to cos x by 2y minus 1. Now the given function is equal to y equal to this. Now squaring on both sides, in the given function if we is taking square on both sides, we get y square is equal to sin x plus root under sin x plus root under sin x plus dot 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 up to infinite. This one. Now this part can be written as y because y is equal to this infinite sum. So we have y square is equal to sin x plus y, that is y square minus y is equal to sin x. So differentiating with respect to x, we get 2y into y1 minus y1 is equal to cos x, that is taking y1 common, we get 2y minus 1 is equal to cos x, or y1 is equal to cos of x divided by 2y minus 1. This is answer. This is problem number 15. Now problem number 16. Problem number 16. If fx is equal to sine of log x, base obviously e, and y is equal to function of 2x plus 3 divided by 3 minus 2x, find dy by dx. This one. What is the derivative of y with respect to x? Now given that y is equal to function of 2x plus 3 divided by 3 minus 2x. So differentiating y with respect to x, we get, if we differentiate this function with respect to x, we will get f dash of 2x plus 3 divided by 3 minus 2x into ddx of this ratio or this quotient, because we know that ddx of composition function f of gx is equal to f dash of gx into derivative of gx. This is the rule of the differentiation. This is the differentiation rule of a composition function f composite c. So here also we find, if we take this f is a function and this is g function, if we consider this is gx, so what is the derivative? Derivative is equal to f dash of this g into derivative of this g. Okay, so f dash 2x plus 3 divided by 3 minus 2x into this one, actually 3 minus 2x whole square, quotient law হচ্ছে 3 minus 2x into derivative of this is equal to 2 minus 3. Now 2x plus 3 into derivative of this is equal to minus 2. Now 3 minus 2x whole square here 6 minus 4x plus 4x plus 6. This one cancel. So we get 12 over 3 minus 2x whole square into f dash of this function. Now f dash of this function, okay, now since now we have fx is equal to sine of log x, so differentiating fx we get f dash x is equal to cos of log x into derivative of log x is equal to 1 by x. So actually we get cos of log x by x. So what is f dash x? F dash x is equal to this. Therefore f dash of this one, so f dash of this one means replacing this x by 2x plus 3 by 3 minus 2x. So we get cos of logarithm of 2x plus 3 divided by 3 minus 2x whole divided by 2x plus 3 divided by 3 minus 2x. Okay, and then simplifying, one part cancel, simplifying we'll get actually 12 into cosine of logarithm of this part divided by this one part cancel this one, so we get only 3 minus 2x into 2x plus 3. This one is the answer. This is problem number 16. Now problem number 17. Problem number 17. If 2y is equal to x into 1 plus dy by dx, prove that d2y dx2 is constant. Given that twice y is equal to x times of 1 plus dy by dx, to prove that second order derivative of y with respect to x is equal to constant. Since we have to show that the second order